Okay, so those are manufacturers and sockets. The most important thing we want to talk about is how we compare them. Because you have to decide when you're buying a computer which kind of processor I should get. Or when you're building a computer, and it should be on how we compare them. Okay, the most common way is speed and hertz. Does anybody remember what hertz stands for? Cycles per second. Thank you very much, Mr. Hammer. Okay, so hertz is 1 cycle per second. And now processors in gigahertz, which is how many?
100,000, 100,000, something like that.
A giga is a billion, okay? So this is in billions of cycles, C-L-E per second. And we'll pretend I didn't. I said it right, though. Okay, so gigahertz is a billion cycles per second.
Whoa. Cycles.
C-Y-C. That's a C.
Cycles.
Here, you need me to fix that? There we go. There we go. It's even messier now. Okay, so now we're looking at the CPU speed, the speed of the processor, in billions of cycles per second. And this is how most people look at the speed of a computer. And it's only one of 3 parts that we're really going to talk about. Okay? It generally means that things are going to process faster. But not totally, because we have to look at all 3 of the things we're going to look at.
Sorry, that's the point.
Okay, so one way is the speed of the processor. That's the first way we look at it. The next thing we look at is the number of cores.
I was writing that.
You were still writing?
Yeah, I got some weirdos tapping over here. It's getting annoying. And then your phone keep beeping back here.
Yeah, that's just driving us.
Why are you writing that
I'm
down?
trying.
Plug in my phone.
Around your big head.
Oh, that's her.
Okay, what is this thing? Billion?
Okay, so the speed of the processor is the first way we compare CPUs. I'm moving on now, which is in how many cycles it makes, because that cycles generally determines how fast it is. Okay?
Oh, good lord.
Second way we look at it is number of cores. Do anybody know how many cores we can have on a computer or a processor right now?
8.
The fastest has 8. It's an octa-core, which means it looks just like this one.
AMD.
It looks just like this one. Just like this one. Okay? But underneath this, or inside this, there are actually 8 processors in here. And an octa-core. This one obviously is not octa-core. It's a single core.
Oh, I thought you were being serious, like octa-core. I'm like, wait a minute, let me see that.
This one is. These are all single cores.
You got a dual?
Not that I'm going to pass around and let us run.
Well, can you just hold it and I want to see it?
No, I don't have any out. Okay? They're in computers. Okay, so it refers to the number of cores. And this may mean that it's faster. Okay? My son's computer is a 3.2 gigahertz dual-core computer, and mine is a 2.8 gigahertz quad-core computer. Which one's faster?
Yours, because I know yours is going to be better than your son's.
The answer is it may be faster depending on what we're doing. When he opens up Skyrim, and I open up Skyrim,
Alright, quick.
his runs faster. It's a game.
Is it sweet? Because I heard someone talking about it.
We can talk about that later. So when I open up a game, the same game as his runs faster because although I have more cores than he does, each one of his cores is faster, and most games and most applications only use one. So here's what's happening. The operating system starts up. Here's a program who looks like they're not doing something. I have 4 cores. This core obviously is sleeping, so I'll give him the program to run it. Okay? Because all cores don't run the same stuff. And when the next program starts up, this one's not asleep, but he's barely moving. I'll give this program to him, okay? So that's what happens when the computer divvies out programs. There are some programs that are smart enough that they can use multiple cores. There are very few. So that's why more cores may mean faster. If I've got a server, what do you think I'd rather have? This one or this one? More cores is better if more things are running at the same time. So if I'm running a server, if I have a PC that I run all kinds of stuff on at the same time, I'm going to set up a PC in the corner that I'm going to mount some wall monitors on so I can monitor the servers. The more cores I have, the more simultaneous things can go on. And that's why it's a May. Because if you're just running one thing, if Haley's working in an office and all she uses is Microsoft Excel, buying a quad-core machine, is it going to be that much faster, or could be slower than running even on a single or dual-core machine? Okay? I will tell you that I think dual-core is the way to go, at least. Because the way it works is antivirus stuff and other stuff can be working on one core. You can tell the operating system what runs on what core. And you can put all your junk that runs in the background on one core, and then the other core just stays open for when I open up a program. And that whole core is free for that. You can go in the operating system and be that specific. Okay, so what? Well, you can do that with a quad, but it's still, his processor is still faster than mine. Okay, so in the case of a game, and most games only use one processor, his is going to run faster, and it does. Okay, the last part of it is memory. Now, we talked about primary storage using RAM, but it also uses a different kind of memory. Stand up. Stand up. Stand up. Stand up. You can't keep our eyes on.
Do we have a
Okay.
time?
Okay. What?
You still got your.
What?
Do we have the water?
We have time. We have time for that today. I just came from lunch. Okay, so the other kind of memory.
Tell him we don't have enough time.
The other kind of memory. The other kind of memory is called cache. Okay, cache is memory that comes on the die. What did I call Celeron before? Do you remember what I called Celeron?
Junk.
I think I used the word crap, but junk works too. Okay, the difference between a Celeron processor and right here I've got two processors. One of them is a Pentium 4 and one of them is a Celeron. Okay, here's the difference. The Celeron processor has 128K of cache. I'm going to put my pen down. Okay, so I'm going to write down all the zeros so we know. So this one
Oh my.
has 128,000. That's how much cache this one has. I'm going to go back, I promise. This one has 128K of cache.
We have to write this down.
No, I'm just trying to explain the difference, what cache does. Okay, and this one has 1 meg of cache. I made too many zeros. I'm a little too big there. Okay. So which one do you think is going to be? Which one is more?
The bottom one.
Okay. This one is how much more?
A lot.
A lot more. Okay. So it's got 8 times more memory on this one than this one. They're both the exact same speed, but this one has 8 times more memory. Which one's going to run faster?
The one with 8 times
The
more
ones
memory.
with 8 times more memory. Now, come on, man, you can do it. Walk around the room. You can stand in the back. You can do the wall touching thing if you need to. Okay, so this one's got to be way faster because it's got more cache. Okay, while it's working, it's got to go to RAM. It's got to go to memory, and the memory on the die is way faster. So if you've got more cache, the computer runs faster. And there's 3 kinds of caches. Okay. L1, L2, and L3.
What's better?
The number refers to how far it is away from the actual processor. And you know, it all looks like the same on these because it's one big, huge die, right? But if you look at this one and think of it the same way, there is a processor, and this is a big circuit board, just like this is. Underneath here, it's a circuit board underneath here. And how close the memory is to the actual processor on it. L1 is on the processor. It's written, and the memory is right there with it, okay? L2 is just off the processor, and L3 is somewhere on the die. It's just on here, okay? So the lower number is better, but they're all still on here. I'm going to explain it like this. I got another picture. This is like a big processor. Pretend that is this, okay? That is this. I've blown it up huge. And these are the different cores. Okay? If L1 is just on it, and L1 exists for that specific core, okay? So that memory is right there on it. L2 exists for that core, but it's right next to it. And L3 is shared in the middle.
So you want more L2 than L3?
Dude, do we have to draw that?
No, you don't have to draw it. You just need to understand that L1's on the die, L2's off the die, and L3 is shared. It's kind of like this, okay? This is a tri-core processor. Actually, Kevin, slide over here. You're part of the processor, okay? And all I do is give them this. Each of them gets one piece of paper here. By the way, is this anybody from this classes?
That's fine. That's fine.
He's doing different paper.
Okay. Is it really?
Yes.
Okay. There's no notes in it, Kevin.
Yes, it
Oh,
is.
there is on the other side.
Oh shoot, he's
Okay. You can have it at the end. So everybody gets this much, and then in the middle of the table is that. So everybody has their L1 or their L2 memory. I've only taken out 8 sheets so far. L1 or L2. 8. You've only used 4 the whole semester.
You better pocket that word.
And then there's the L3 in the middle. Everyone gets to share it.
Mine's dirty. I need another piece.
Okay? Everybody gets to share it, but there's only so much. You can't put it back in the folder. Is that really yours?
Yes.
Okay, you
Hey,
should
Brandon,
do
I'll
it.
share it with you.
How about this one? Is this one anybody?
Yes. That's one of yours. No, it's not.
Dude, I'd take that one and I'll eat
Okay, so do we have understand the difference between L1, L2, and L3?
Exactly.
L3 is shared. L1 and L2, each processor has their own.
I took
Here,
pictures.
hit the next button.
See my pictures?
Yeah.
Okay, so I'm going back to this again.
Oh, we didn't hit back.
Okay, so more cache means less use of RAM, which is less stuff that goes around the motherboard. The more cache you have, cache, C-A-C-H-E is pronounced cache, like C-A-S-H. Cache.
Yeah, it's just spelled different, but pronounced the same.
Dude, I'm just gonna.
It's pronunciation.
Okay? More cache means faster processing. Did I move on yet?
Yeah.
Okay,
It's about time.
so